Let's take a look at this example. Cosine of theta plus 1 over tangent squared theta equals cosine theta over secant of theta minus 1. Now, there are two ways of doing this. I think one way is decidedly easier than the other. And that way is to rationalize the denominator that we have here on the right by multiplying times secant of theta plus 1 in both the numerator and the denominator. And again, the reason for that is so that in the denominator we have a square, where we have the difference of squares, and that would give us secant squared theta minus 1. Now, you may remember this little nugget that says that tangent squared plus 1 equals secant squared. So if I were to move the 1 over, secant squared minus 1 equals tangent squared. So in the denominator, this becomes tangent squared. Now, in the numerator, you can distribute the cosine and have cosine theta times secant theta, and then plus cosine theta. But remember, secant of theta is just 1 over cosine, right? So since this is really 1 over cosine, when you multiply times cosine, you end up with just 1 plus cosine theta over tangent squared. And that's what we were supposed to have, right? Now, I just say cosine theta plus 1, but because it's a sum, it doesn't really matter. You can write it either way. So yay, another identity that has been verified. All right, this one here is a doozy. So we have secant of theta minus tangent of theta, quantity squared, plus 1 divided by secant of theta, cosecant of theta, minus tangent of theta, cosecant of theta. And all of this is supposed to equal 2 times the tangent of theta. So I hope it's pretty clear to you that we should start with the stuff that we have on the left, because there's a lot more to work with, and hopefully we can somehow condense all of that to give us what's on the right side. Now, to do that, I recommend that you start off by squaring everything. Not squaring everything, but squaring the secant minus tangent. So big fraction here, when I square this, we get secant squared theta minus 2 secant theta tangent theta plus tangent squared theta, and then we have the plus 1. And not really a whole lot that we can do in the denominator right now, except just rewrite all of this stuff. Now, the next step, we will talk about doing some factoring. But right now, just bring it all down. In the numerator, we see this. We see tangent squared plus 1. That is straight up a Pythagorean identity, which will give us secant squared of theta. Okay. So let's combine that with the other secant squared that we have. So that's 2 secant squared theta minus 2 secant theta times tangent theta. Again, all over the stuff that's here in the denominator. And that's going to be this next step where we will look to factor. So in the numerator, please notice that you have a factor of secant here and here. And then in the denominator, you have a common factor of cosecant. So let's factor those out, and let's see what we have. So big fraction, we're going to factor out, not just secant, but we've got a 2 there. So let's go and factor both of those out. So take out 2 secant of theta, and we'd be left with secant theta minus tangent of theta. In the denominator, our common factor was cosecant of theta. And we factor that out to be left with secant theta minus tangent theta. Oh, isn't this nice, right? So since these guys are the same factor, they reduce. And I have 2 secant theta over cosecant theta. Now keep in mind where we're supposed to be. We're supposed to end up with a tangent on the right side. So we can get there because we've got the 2. Remember that secant is going to be the reciprocal of cosine, so it puts cosine in the denominator. Cosecant is the reciprocal of sine, so it puts sine in the numerator now. And there you have it, 2 times the tangent of theta. That's exactly what we were trying to find, and we're done. So this had a couple of interesting steps to it. One was making sure that we could take that quantity square and multiply it out. We were able to identify that there was a Pythagorean triple that was being in use right there. Combining like terms, we were able to see that we had common factors with the secant of thetas in the numerator and cosecant of theta in the denominator, leaving us with factors that were common in both the numerator and denominator. They reduced. And then and this is a very common thing that we do. Sometimes it's kind of hard to see where we're supposed to go, but if we convert everything into sine and cosine, a lot of times the solution will present itself. So you just have to be patient. And again, got to try something.